Hello, everyone. I'm Marcy Scudder. For this project, I explored Minecraft Education Edition as a virtual world learning environment. As a children's public librarian, I'm constantly thinking about how to create meaningful, community centered learning experiences. Many of the children I work with are already deeply engaged with Minecraft, so I wanted to explore how that existing interest could be leveraged for intentional learning. This lesson is designed for upper elementary students in a public library program where learners collaboratively design and build a functioning community within a virtual world. The goal is not just engagement, but developing spatial reasoning, collaboration, and applied problem solving skills. Minecraft Education Edition is a persistent multiplayer virtual world where learners interact through avatars and collaboratively construct shared environments. Unlike a static stimulation, this platform is dynamic and responsive. Every action transforms the environment in real time. This aligns with key characteristics of virtual worlds, including spatial immersion, avatar based interaction, and collaborative world building. Importantly, learners are not simply navigating content, but they are actually actively shaping it. This distinction is critical because it shifts students from passive consumers to active producers of knowledge. In these screenshots, we see several key features of the environment. First, learners entering a shared world. This establishes spatial presence and a sense of belonging within a digital environment. Next, collaborative building, which is multiple users contributing to a shared structure. This demonstrates distributed problem solving. We also see avatar interaction, where students coordinate actions and negotiate decisions in real time. Another image highlights environmental manipulation, which is the ability to shape and reshape the world. And finally, the completed build represents a collective artifact, a tangible outcome of collaborative learning. What's important here is that learning is embedded in action. Students are not just observing, however, they are designing, testing, and refining ideas with a shared space. By the end of this lesson, students will analyze how different elements contribute to a functional community design, collaborate to construct a shared structure within defined constraints, and apply problem solving strategies to address challenges that emerge during the building process. These objectives are intentionally measurable and aligned with both the activity and the final assessment, ensuring instructional coherence. Lesson flow. Before entering the virtual world, students activate prior knowledge by discussing what makes a successful community, including infrastructure, shared spaces, and accessibility. We also establish clear expectations for collaboration and introduce relevant vocabulary. During the activities, students work in small groups with defined roles such as planner, builder, and resource manager. This structure is important because it prevents the experience from becoming unstructured play. The cognitive task here is collaborative problem solving. Students must negotiate, adapt, and make decisions together. After the activity, students engage in structured reflection. They explain how their design contributes to the overall community and evaluate the effectiveness of their decisions. This ensures that learning extends beyond the immersive experience into meaning making. Pedagogical framework. This lesson is grounded in constructivist learning theory. Constructivism emphasizes that learners actively construct knowledge through experience rather than passively receiving information. Minecraft supports this by providing an environment where learners generate meaning through interaction, experimentation, and collaboration. Knowledge is not delivered, but it is built. Additionally, the social nature of the platform aligns with social constructivist principles where learning emerges through dialogue and shared activities. This makes the virtual world not just a tool, but a context for situated learning. Challenges and risks. Despite its strengths, there are important challenges to consider. First, access and digital equity. Not all libraries have sufficient devices or bandwidth. Second, the potential for distraction. Without structure, the environment can easily shift from learning to entertainment. Third, safety and moderation concerns in multiplayer spaces. And finally, cognitive overload. The open ended nature of the environment may overwhelm some learners. A critical approach requires acknowledging these limitations rather than assuming that technology is inherently beneficial. Mitigation strategies. To address these challenges, I would implement structured rules to maintain focus and accountability. Time limits would be established to prevent cognitive fatigue. Students would follow guided design prompts aligned with learning objectives. And in cases of limited access, device rotation models would ensure equitable participation. These strategies support both instructional clarity and inclusive access. Why a virtual world? Minecraft enables something that traditional tools cannot, which is collaborative world building within a shared persistent space. Students don't just describe a community, but they construct and inhabit it as well. This allows for experimental learning where understanding emerges through doing. The key outcome strengthened here is spatial and relational thinking, which is difficult to achieve through text or static images alone. This represents transformational use, not simple substitution. Last, I will end with this question. When does collaborative virtual play transition into meaningful learning? And what instructional structures are necessary to support that shift? This concludes my presentation. Thank you very much.